By now, you should be fairly familiar with our shopping list application that we've been building. You can enter the name of the item, the quantity of the item, click Add Item, and it will appear in a list right below this form. In this version of the shopping list, number one is we're going to assume that the quantity is actually just a number, and that's why I put the word boxes right here to signify so many boxes. And number two, in order to prevent me from gaining weight, we're going to have a special service that's going to examine the item name and make sure there's no word cookie in it. If there is, it will prevent me from adding that item to my shopping list. Likewise, we will also examine the quantity, and if the quantity is anything greater than 5, the service will likewise prevent me from putting that item on the list. Now, since analyzing the item name could be a very complicated process and therefore can take a long time, we're going to implement that in an asynchronous fashion. Analyzing the quantity will also be asynchronous. What that will mean is that when we click Add Item, the item will not immediately appear below the form, but will first get analyzed and then decided whether or not it should even appear, and if it does, only then will it appear a couple of seconds later. Let's take a look as to how I implemented that. Okay, so I'm in my Atom editor, and I'm located in Lecture 24 folder, which is in Full Stack Course 5 Examples folder. And this is our shopping list promise app. And as you've seen before, it's just one controller with two bound text boxes for item name and item quantity, and a button that's bound to list.addItem. Right below that, we have our ordered list that will go ahead and loop through our items, our item array, and will give us the quantity, boxes of, the name of the item, and a button to remove that from the list. Let's take a look at our app.js. In our app.js, besides declaring the controller and the shopping list service, we also declare one more service called weight loss filter service. Well, let's take a look at the shopping list service first, because that is what our controller is going to directly invoke. So here's our shopping list service, and you can see we're injecting it with this service called weight loss filter service. Don't worry about the $Q for now. We're not going to be using it for now, but we will use it in a minute. So you could see that the add item method inside of our shopping list service is something that's using asynchronous behavior by calling weight loss filter service.check name. So what we're doing is we're checking the name to make sure that we're allowed to put that on our shopping list. So we could use the then method and say promise then and get the response. And before we use the response, we want to make sure that the quantity is likewise acceptable. So we're going to call the weight loss filter service again inside of our then function, the success then function, and we're going to get the next promise. The next promise then will call the then function again, and only then, if that everything is checking out, we will go ahead and push that new item that we're going to create onto our items array. If this next promise fails for whatever reason, we're going to go ahead and output the error message to the console. Likewise, if the outer promise fails, we're going to do the same thing. We're going to output the error message to the console. So far, so good. Let's go ahead and check out our weight loss filter service. We scroll down. There's lots of commented out code, but here's the weight loss filter service. And it depends on the queue service and the timeout service. The timeout service is the same as the set timeout of JavaScript, except it's angularized, so you don't have to manually call $apply or $digest. Here's our method check name. And the check name method first acquires our deferred object that contains the environment for the entire asynchronous behavior, and sets up this result with a simple message, which in this case is just an empty message so far. Then we're going to go ahead and execute our timeout function that's going to simulate our asynchronous behavior. And we're going to do this very complicated algorithm of figuring out whether or not Yaakov is trying to put anything that has to do with cookies as part of his shopping list. Basically, we're not really doing anything complex. I was just joking. All we're going to do is we're going to lowercase the name, the item name, and then see if the word cookie appears anywhere in that name. And if it does not appear, then we'll go ahead and resolve it, meaning it's going to be successful with the result, which in this case is just an empty object really with just one message property that is an empty message. However, if we find a cookie as part of the name of the item, We're going to set the result.message to stay away from cookies, Yaakov, and then we'll call deferred.reject, which will complete our promise unsuccessfully, passing it the result so we could retrieve that error message from there. Note that what you name these arguments makes absolutely no difference. It's just going to get retrieved from the promise inside of the then function. And the timeout is going to wait 3 seconds before this entire functionality is executed. Last but not least, we need to return the promise back to the caller of this function, so they can have a hook to tap into, whether that's going to be a rejection of our asynchronous behavior or a resolution of it by resolve or reject method. Note that the check quality method is basically identical. The only difference here is we're checking the quantity to be less than 6, as opposed to checking whether the word cookie appears as part of the item name. The only other difference is that we're going to wait only 1 second instead of 3 seconds to execute this behavior. And the error message is going to say, that's too much, Yaakov, instead of saying stay away from the cookies. Let's go ahead and save that and go back to our browser, and we'll try to put something like chips, and we'll say we need 3 boxes of chips. And let's go ahead and click add, and we'll count about 3 seconds, and another second after that, and 4 seconds later we see that we have 3 boxes of chips. Now let's try to go ahead and get around the system by saying we're going to have cookie flavored chips, and we'll get 3 boxes of those. We'll click add item, and about 3 seconds later we see that it says stay away from cookies, Yaakov, in our console, and there's no item that is added to our list. Now what happens if I say chips again, but this time I'll say 6, so 1 more than 5, and click add item. It will go ahead and check that cookies are not part of the item list, and then it will check and see that 6 is really greater than 5, and therefore it's going to say that's too much, Yaakov. It will reject the promise, and therefore we're not going to see another item on our list. Okay, so far so good, but let's go back to our code that we used to handle the promise, and let's take a look as to how we're handling that promise. It's a little bit messy, right? Even though this is not callbacks, it still kind of looks like callbacks. There's just a lot of indenting and just a lot of code, and it's hard to understand what's calling what. Let's go ahead and rewrite this function and make our code much cleaner. We'll comment this out, and I already have a second version of it sitting right here. We'll uncomment that, and let's go over this code. This is that same add item method on our shopping list service, and I'm still calling the weight loss filter service check name. But I'm grabbing this promise, and when I call the then method on this promise, I don't even supply to it the second function that's supposed to handle an error. The reason I don't do that is because if there is an error, it will go ahead and bubble up and propagate, and I could call the then method on that again, which will once again return a promise, and then I could call the special method called catch, which will get executed when deferred.reject gets invoked. Now in the original promise.then, all I have to do is execute our weight loss filter service that checks the quantity now of my item in the shopping list. And since that returns a promise, I could just return that, which will then get picked up by the next then method. The reason I don't really need to do anything here is because I know that my response object is just an empty object with an empty message. In other words, if we're in this code block, that means we succeeded and we need to do nothing else other than check the quantity for validity. The next then method treats the response the same way, because if we got to this code block, it means that the check quantity passed and we're allowed to add the item or push the item onto our array of shopping list items. So note what we did here. We no longer have to handle the error condition or the rejection of the promise in every single case. We only have to do this once, and we could do it centrally. So certainly that's much easier to read code and much cleaner. Let's go ahead and save that and see if this works. Let's go back to our browser, and we'll say cookies. We'll give it 4 boxes of cookies. We'll click add, and that will be an error condition, and therefore we'll stay away from cookies. If we say chips and click add, about 3 to 4 seconds later, it should go ahead and add that 4 boxes of chips. And if we leave it as chips, but put, let's say, 7 boxes, click add, that will also resolve, but resolve with a rejection, and then therefore it will say that's too much, Yaakov, because our catch method right here is catching any errors from any of the promises that were chained above it. Okay, so far so good, but we can improve it even more. Let's take a look as to what's going on when we try to add a valid item but with too many boxes. Let's go ahead and clear this and click Add once again. Take a look as to how long that takes. It takes about 4 seconds. Now why should it take 4 seconds? Checking this item takes 1 second. Checking this item takes 3 seconds. We know that if either of these items isn't valid, I want to go ahead and output an error message and just forget the whole thing about adding it to my list. So why should I wait to execute the validation of my number of boxes after I validated the item name? They really should be executed in parallel. So let's go ahead and code that up. Let's go back and we'll go ahead and once again comment out this version of the add item method and uncomment yet another version of the add item method. And this one does both things in parallel. And the way we do that is by capturing the name promise, which is the return result of the weight loss filter service check name method that returns a promise. And then we're going to capture the quantity promise, which is the result of executing weight loss filter service check quantity method. And here we're going to use our queueService.all. And what that takes is an array of promises. We can then call the then method on that, which will only get executed once every single promise in this array is resolved. However, if any of the promises in this array result in a rejection, meaning deferred.reject, all promises will be canceled immediately and the execution will jump into the catch method, outputting this error response message. That means that if this promise takes much faster to execute and much faster therefore to fail than this promise, I don't have to wait for this promise to finish in order for me to just cancel the whole execution and output the message. Now the quantity promise takes about a second to execute, whereas the name promise takes about 3 seconds to execute. Let's go ahead and save that and let's go back to our browser. If I now enter chips in here and quantity 3, meaning a valid item with a valid quantity, when I click add, that will take about 3 seconds to execute, not 4. Since we're doing both validations asynchronously, the longer one will run its 3 seconds, but by the time it's done, the one that takes shorter amount of time would have finished already. Now if I enter cookies in here, that will also take 3 seconds, and 3 seconds to actually fail. And you can see it fails, rejects it, and says stay away from cookies, Yaakov. And that's also because that's the longer one, and therefore the 3 seconds it took to fail is the all-encompassing time. But look what happens if I say chips and then enter something invalid like 7 for quantity. When I click add item, take a look how fast that fails. It fails almost right away, which about a second later it says that's too much, Yaakov. We could actually do that again. Click add. And you can see that it fails right away. So with the construct of $$all, we're able to put multiple promises, actually as many as we want, and they will all try to execute asynchronously, making our entire app potentially much faster as well. Okay, let's summarize what we learned in this lesson. First of all, let's remember that promises give us a lot of flexibility when dealing with asynchronous behavior. The queue service is the Angular implementation of the Promise API. The new implementation of JavaScript ES6 has its own Promise API and will likely use that once it's supported by all the major browsers. Promises either get resolved or rejected. Resolved is considered a success and a rejection is considered a failure. The then method that you could call on the promise takes 2 arguments, both of which have function values. The first is a function to handle the success or the resolve outcome, and the second is a function to handle the error or the reject outcome. In addition, then method itself returns a promise, so you could chain it with other promises and make the code a bit more readable as well. Finally, we spoke about the queueService.all method. That method allows us to execute multiple promises in parallel. making things faster, and at the same time, we're able to handle success and failure of all of those promises in one central place in our code.